Hello students, hope you are doing well. In this video, we are going to discuss Introduction to IP version 6 of Unit 5, Designing IP Addressing in the Network and Selecting Routing Protocol for the subject Enterprise Network Design of B7 Semester IT, University of Mumbai. IP version 6 is a technology developed to overcome the limitations of current standard, that is IP version 4, which allows end system to communicate and forms the foundation of internet as we know it today. So in this lecture, we are going to discuss IP version 6 features, IP version 6 address format, IP version 6 address types, IP version 6 address assignment, IP version 6 name resolution, IP version 4 to IP version 6 transition, strategies and deployment, and IP version 6 routing protocols. IP version 6 features the ability to scale network for future demand requires limitless supply of IP address and improved mobility. IP version 6 combines expanded addressing with more efficient and feature-rich header to meet these demands. IP version 6 satisfies the increasingly complex requirement of hierarchical addressing that IP version 4 does not support. The Cisco iOS supports IP version 6 in release 12.2, 2T and later. The main benefit of IP version 6 includes larger address space. IP version 6 addresses are 128 bit, okay, 128 bit IP version 6. With this, we can generate 2 to the power 128 addresses. In case of IP version 4, the size is 32 bit. Therefore, we may be able to generate only 2 to the power 32 addresses. So, as compared to IP version 4. This larger addressing space allows more support for addressing hierarchy level, a much greater number of addressable nodes, and simpler auto configuration of addresses. Then come to global unique IP address. Every node can have unique global IP address, which eliminates the need for network address translation, that is NAT. Then site multi-homing. IP version 6 allows hosts to have multiple IP version 6 addresses and allows network to have multiple IP version 6 prefixes. Consequently, site can have connections to multiple ISPs without breaking the global routing table. Then header format efficiency. A simplified header with a fixed number of header size makes processing more efficient. Improved privacy and security. IP version 6 with IP security is the IETF standard. Okay, this is IETF standard. What is IPsec? For IP network security available for both IP version 4 and IP version 6, although the functions are essentially identical in both environment. IPsec is mandatory for IP version 6 and IP version 6 also has optional security headers. Then come to flow labeling capability. New capability enables the labeling of packets belonging to particular traffic flows for which the sender requests special handling such as non-default quality of service or real-time services. Then increase mobility and multicast capabilities. Mobile IP version 6 allows IP version 6 node to change its location on IP version 6 network and still maintain its existing connection with mobile IP version 6. The mobile node is always reachable through one parameter address. A connection is established with a specific parameter address assigned to mobile node, and the node remains connected no matter how many times it changes location and addresses. So this is the beauty of IP version 6 address. IP version 6 address format. Rather than using dotted decimal format, IP version 6 addresses are written as hexadecimal number with colon between each set of 4 hexadecimal digits, which is 16 bit. We like to call this as colon hex format, okay, and the IP version 4 notation like 192.168.1.1, this is known as dot separated notation, okay, and this is colon hexed format. Fine. So here in this format, the format is written as x colon x colon x colon up to where x is a 16-bit hexadecimal field. Okay, x colon x colon. If we divide 128 divided by 16, so how many these numbers are coming? So 16 ones are 16, 62s are 32, and likewise it is, you can calculate directly. 4 fours are 16, 4 threes are 12, 2 and 8. So this x is in 8 number. Okay, 5, 6, 7 and 8, where this particular x represents 16-bit number. Okay, 16-bit hexadecimal number. Fine. So this is a simple example of this notation. 2035 colon 0001 2BC5 0000 all separated by colon. Fine. Now, fortunately, you can shorten the return form of IP version 6 address. Leading 0 with each set of 4 hexadecimal digit can be omitted and a pair of colons can be used. Okay, so once within address to represent any number of successive 0. So here we have written 2 pair of zeros and 2 pair of zeros. So in this particular pair of zeros, we can write 4 number of colons here. It shows the 2 pair of zeros are there. Okay. Similarly, in this case, because after C, here 2 uh, 4 means 4 cross 16 and 4 cross 16 bits are there, means all the 4 digits are, or 4 numbers are, 4 hexadecimal numbers are used as 0 and 4 numbers are used as 0. In this case we use 2 number of colons. It shows that this block is 0 and this block is 0, while in this particular case only this block is 0 but some zeros are there in this block. So instead of writing this 4 means whole pair of 0, we just write 0 in up and finally the last digit as a. Okay, so this is the shortening process of IP version 6 address format. Clear? A pair of colon can be used only once within an IP address. So you can use it only once. Fine. Only once. Means if another pair is coming, you cannot use this. This is because an address parser identifies the number of missing 0 by separating the two parts of entering 0 until 128 bit are complete. If two colon notations were uh, to be placed in the address, there would be no way to identify the size of each block of zeros. Similarly, similar to how IP version 4 subnet mask can be written as a prefix, for example, /24, IP version 6 uses prefixes to indicate the number of bits of network or subnet information. Okay, like 24 is written, so this shows prefix and to identify the subnet mask. So let us discuss IP version 6 header format. Okay, here IP version 4 header format is also given and IP version 6 header format is also given. So fields name kept from IP version 4 to IP version 6 is shown in yellow, like version is there and version is there. Similarly, source address and destination address are common. Although the size of source address and destination addresses are not same, but this is the common field. Field not kept in IP version 6. So these fields are not taken in IP version 6 like IHL, identification flag, fragment offset, header checksum, option and padding. Name and position change in IP version 6 like type of service. Here traffic class, payload length, okay, total length. Then next header and protocol, hope limit. These are the things identified differently. And the new field in IP version 6 is this flow label. So only small field, only one field is included in IP version 6. And some fields are not taken from IP version 4. So therefore, the IP version 6 header format is very small. Means if we see the size is larger obviously, but we need not to go for flags, fragment offset, header checksum, etc. options. Okay, so this is very simple. Now come to discussion of each and everything. The IP version 6 header has 40 octet. How many octets are there? 40 octet. In contrast to 20 octets in here, 20 octets are there. Okay, so IP version 6 has fewer fields and header is 64-bit aligned to enable fast, efficient hardware-based processing. The IP version 6 address field are 4 times larger than IP version 6. Clear? The IP version 4 header contains 12 basic header fields followed by an option field and data portion which usually include transport layer segment. The basic IP version 4 header has fixed size of 20 octets. The variable length option field increase the size of total IP version 4 header. IP version 6 contains fields similar to 7 of 12 IP version 4 basic header fields, 5 plus the source and destination address field, but does not require the other fields. The IP version 6 header contains version. Version is used for a 4-bit. Okay, this is 4-bit version field, same as IP version 4. For IP version 6, this field contains the number 6. Okay, so you need to write 0 1 1 0. For IP version 4, this field contains 4, that is 0100. Okay, so this is the thing here in version. Next field is traffic class. So traffic class is an 8-bit field. Okay, and it is similar to type of service. Okay, type of service is given here. It is very similar to this TOS field in IP version 4. The field tags that the packet with a traffic class that it uses in differential service, tip serve, quality of service. These functions are same for IP version 6 and IP version 4. Then come to flow label. This is 20-bit field. 20-bit field. Okay. In new IP version 6, it can be used by the source of the packet to tag the packet as being part of specific flow, allowing multi-layer switches and routers to handle traffic on per flow basis rather than per packet. For faster packet switching performance, the field can also be used to provide quality of service. Then come to payload length. Payload length is, it is 16-bit. Fine, 16-bit field. So this is similar to IP version 4 total length field. Okay, total length field. It is also 16-bit. So here also 16-bit field. Now come to next header. Next header is the field 8-bit long, and this is also 8-bit long. The value of the 8-bit field determines the type of information that follows the basic IP version 6 header. It can be transport layer information such as transmission control protocol or user datagram protocol, or it can be extension header. The next header field is similar to protocol field of IP version 4. Now come to hop limit. This is 8-bit field, specifies the maximum number of hops that an IP version 6 packet can traverse, similar to the time to live TTL field. Okay, that is very similar to TTL field. Here it is given TTL field. So hope limit and TTL are the similar field. Each router decreases this field by 1 because there is no checksum in IP version 6 header. An IP version 6 router can decrease the field without recomputing the checksum. In IP version 4 routers, the recomputation costs processing time. Okay. If this field ever reaches 0, a message is sent back to the source of the packet and the packet is discarded. So this is 8-bit in length and maximum answer for this is 255. Okay. So 55 up to 0. Now come to source address and destination address. So these are 16-bit. Actually, these are the 16 octet fields. Okay. Total 128 bits. Clear? Here, how many 16 bits are there? 8 16 bits are there. So 16 8 bits are there. So it identifies the source of packet and it identifies the destination of packet. Now come to extension headers. Extension header is not shown here, but extension header is also included. The extension header, if any, the data portion of the packet follow the other 8 field, the number of extension header is not fixed. So the total length of the extension header chain is variable. Notice that the IP version 6 header does not have a header checksum field because link layer technologies perform checksum and error control and are considered relatively reliable. An IP version 6 header checksum is considered redundant. Without the IP version 6 header checksum, upper layer checksum such as within a UDP are mandatory for IP version 6. IP version 6 address types. Similar to IP version 4, single source can address datagrams to either one or many destinations at the same time. So this is defined under RFC 4291. RFC 4291 IP version 6 addressing architecture. IP version 6 addressing architecture. Okay. So this is the definition from IP version 6 RFC 4291. Let us start each one in detail. First one is Unicast 121. Similar to IP version 4, Unicast address and IP version 6 Unicast address is for single source to send data to a single destination. A packet sent to Unicast IP version 6 address goes to the interface identified by the address. The IP version 6 Unicast address space encompasses the entire IP version 6 address range, with the exception of FFF double F double zero colon slash 8 range. Address starting with binary 11111111. Okay, which is used for multicast address. This is used for multicast. Fine. So the IP version 6 unicast address section discuss the different type of IP version 6 unicast address under document RFC 4291. Now come to anycast 1 to nearest. Anycast is 1 to nearest. Fine. What is that? An IP version 6 Anycast address is a new type of address that is assigned to set of interfaces on different devices. An Anycast address identifies multiple interfaces. A packet that is sent to an Anycast address goes to closest interface as determined by the routing protocol being used, identified by Anycast address. Therefore, all nodes within the same Anycast address should provide uniform service. Okay, so this is responsible for uniform service. Okay, Anycast addresses are syntactically indistinguishable from global unicast address because Anycast addresses are allocated from the global unicast address space. Nodes to which the Anycast address is assigned must be explicitly configured to recognize the Anycast address. Anycast addresses must not be used as the source address of IP version 6 packet. Examples of which Anycast addresses could be used are load balancing, content delivery services, and service location. Like an Anycast address could be assigned to a set of replicated FTP servers. A user in China who wants to retrieve a file would be directed to Chinese server, whereas a user in India would be directed to the Indian server. Next, come to multicast, that is one to many. Okay, in this it is similar to IP version 4 multicast, and IP version 6 multicast address identifies set of interfaces in a given scope, typically on different devices. The packet sent to multicast address is delivered to all interfaces. Delivered to all interfaces identified by the multicast address in a given scope. Okay, in a given scope. IP version 6 multicast address have 4-bit scope identifier. 4-bit scope identifier. Okay. To specify how far the multicast packets may travel. IP version 6 has no concept of broadcast address. Okay. There is no concept of broadcast addresses. Multicast addresses are used instead. Now, an IP version 6 address is valid for a specific scope which defines the type of application the address is suitable for. A single interface may be assigned multiple IP addresses of any type like unicast, anycast, and multicast. So, interface identified in IP version 6 addresses. Okay. In IP version 6, a link is a network medium over which network nodes communicate using a link layer. Interface ID in IP version 6 address are used to identify a unique interface on a link. They can be thought of as host portion of IP version 6 address. Interface ID are required to be unique on link and can also be unique over a broader scope. When the interface identifier is derived directly from the data link layer address of the interface, the scope of identifier is assumed to be universal or global. Interface identifiers are always 64-bit. Okay, these are always 64-bit and are dynamically created based on the data link layer. Like the interface ID used by is based on MAC address of the interface and is in extended universal identifier, that is 64-bit EUI European 64 format. The EUI 64 format interface ID is derived from the 48-bit link layer MAC address by inserting the hexadecimal number FE between the upper 3 bytes. So here it is FF and FE is inserted, and between that 48-bit is there. So this is your MAC address. Okay. So here MAC address is there, and then FF and FE is inserted. And the lower 3 byte, the vendor code or serial number field of the link layer address. The 7th bit in the higher order byte is set to 1, equivalent to IEEE G or L bit to indicate the uniqueness of the 48-bit address. So here the unique field is also given. Okay, so here you can see that this is your MAC address. MAC address is 1-to-1 correspondence is given here, and in between these separations, okay, here FF and FE is inserted. Okay, so this is 48-bit MAC address, and between means 48 divided by 2 is 24. 20 from 25th bit and up to this last bit of this is means here total 16-bit is inserted, and after that the remaining portion of the MAC address is inserted. So this will give you EUI number. Okay, this is also a unique number, and this why this is given, This will say that this is our MAC address, and this will automatically become the unique number. Here, if we insert this, here also we can see that 00 is written. 00 can be 4 times 0 and 4 times 0. Here in this bit, that is 7th bit from left, is unique identifier. When it is written as 1, it means 0 0 or 0 2. If it is 0 0, then it is not unique, and if it is 0 2, then it is unique. Okay, so here unique bit is also inserted, so this will complete the EUI. Cisco device bit flip the 7th bit. Okay, this is the 7th bit from left. Okay, not from the right. So this is how you can use the interfaces. Let us now discuss IP version 6 unicast address. Okay, so there are different type of unicast addresses in IP version 6, like global aggregatable address. This is also known as global unicast address, link local address, and IP version 4 compatible IP version 6 address. There are different formats. So IP version 6 and IP version 4, you already know where it is used. Every IP version 6 enabled interface must contain at least one loopback address. Okay, so this is denoted by colon 1/128 and one link local address. Optionally, an interface may have multiple unique local and global addresses. So this is the thing. And now come to the IP version 6 global aggregatable unicast addresses are equivalent to IP version 4 unicast addresses. The structure of global aggregatable unicast address enables summarization or aggregation of routing prefixes so that the number of routing table entries in the global routing table can be reduced. Global unicast addresses used on links are aggregated upward through organization and then to intermediate level ISP and eventually top level ISP. A global unicast address typically consists of a 48-bit global routing prefix. Okay, a 16-bit subnet ID. This is 16-bit subnet ID and 64-bit interface ID. This is your 64-bit interface ID. Typically in a EUI 64-bit format. Okay, already shown here that 48-bit MAC address, in between that 24-bit MAC address, 24-bit MAC address, and in between this space 16-bit. Here we use FFFE. So this will give us EUI format ID. The subnet ID can be used by individual organization to create their own addressing hierarchy using subnets. The field allows an organization to use 2 to the power 16 subnets. Okay, that is the number 65536 individual subnet. A fixed prefix of binary 2000::3 2000::3, this is binary 001. Okay, if we see this binary 001 sorry 0001 0, then 11 0000. Likewise, so if we calculate this number, this is 2, then 0, then 0, and then 0. Fine. :/3 is indicates a global aggregatable IP version 6 address. This is the current range of IP version 6 global unicast address assigned by IANA. IANA is Internet Assigned Number Authority. Okay, IANA. Here you can see your MAC vendor also. So for this purpose, iana.org, go to this, and so many interesting things you can find here. The 64-bit interface ID field identifies the interfaces on link, and therefore it must be unique on the link. RFC 3587 RFC 3587 defines this global unicast address format. Fine. Now come to link local address. A link local address is useful only in the context of local link network. Its scope is limited relevance to only one link. A link local address is an IP version 6 unicast address that can be automatically configured on any interface by using link local prefix. That link local prefix is FE8010. Okay, so how do means here it starts with 001, fine, and this starts with 4 times 1, then 3 times 1 0 and 1 0, and if we write this as again 00, then it will become, this is F, next one is E, next one is 1008, and then 0000, okay, 0000, so this is 80 and colon slash 10, fine. So many zeros are there, the remaining bits are 0, fine, and 64-bit interface ID is also there. So remaining these bits, how many bits are there? 64 minus 10, that is 54 bits are also 0, that's why it is written as this. Link local addresses are used in neighbor discovery protocol and dynamic address assignment process. Dynamic address assignment is discussed more detail in different places like RFCs also. A link local unicast address connect devices on same local network without requiring globally unique address. Many routing protocol also use link local addresses. When communicating with the link local address, the outgoing interface must be specified because every interface is connected to this. Okay, so link local addresses from means these 64 bit are fixed. These 64 bits are fixed and this depends on MAC and EUI. Okay, so already told that how this MAC is divided. MAC is divided as MAC 3 and MAC 3. Between this 16 bit we use FFFE. Okay, so this will give you EUI standard 64-bit interface ID. IP version 6 assignment strategy. As with IP version 4 and IP version 6 allows two address assignment strategies, that is static and dynamic. Okay. So static IP version 6 assignment. Static address assignment in IP version 6 is same as IP version 4. The administrator must enter the IP version 6 address configured manually on every device in the network. Now come to dynamic IP version 6 assignment. IP version 6 dynamic assignment strategies allow dynamic assignment of IP version 6 addresses as first thing is link local address. Okay. The host configures its own link local address autonomously using the link local prefix FE80 already shown in previous slide. FE80 ::0 slash 10 and 64-bit identifier plus 64-bit identifier in EUI standard. Okay, then stateless auto configuration. A router on the link advertise either periodically or at the host request network information such as 64-bit prefix of the local network and its willingness to function as default router for the link. Hosts can automatically generate their global IP version 6 addresses by using the prefix in this router message. The host do not need manually configure or uh, help of a device such as DHCP server. Like in this figure, a host using the prefix advertised by the router as 64-bit of its address and the remaining 64-bit contains the host 48-bit MAC address in an EUI format. So subnet prefix is there plus MAC address and MAC address is in written in, again I am telling you that MAC 3 16-bit then MAC 3. What is MAC 3 and MAC 3? This MAC 3 is upper 3 octet 8 cross 3 and lower 3 octet, fine, and this is the FFFE, fine. So this will generate the stateless auto configured number. stateful using DHCP for IP version 6. So this is coming under DHCP version 6. DHCP version 6 is an updated version of DHCP for IP version 4. DHCP version 6 gives network administrator more control than stateless auto configuration and can be used to distribute the other information including the address of the DNS server. DHCP version 6 can also be used for automatic domain name registration of host using dynamic DNS server. DHCP version 6 use multicast address. IP version 6 name resolution. How do we resolve the name? So here there are different methods like static name resolution and dynamic name resolution. So let us discuss each by one. Static name resolution accomplished by manual entries in the host local configuration file. Fine. So this is very simplest means to remember. It is very simple, but it is not that simple. And dynamic name resolution accomplished using a DNS server that supports IP version 6 usually along with IP version 4 support. In this figure here we can see that how do we assign. Okay, an IP version 6 aware application requests the destination hostname IP address from DNS server using a request for A6 record. An A6 record is a new DNS feature that contains an address record for IP version 6 host. A6 it is very easy, address for IP version 6. Okay, and then that contains an address record for IP version 6 host. The task of querying for address is done with the name resolver, which is usually part of the operating system. The network administrator must set up appropriate DNS server with IP version 6 support, connect it to the IP version 6 network with valid IP version 6 address. The host must also have IP version 6 address. Next, so this is dynamic name resolution. How do we resolve the dynamic name? So here in this example, www.cisco.com and IP version 6, then IP version 6, and it will give the name. It will resolve the name, not give. Now come to IP version 4 and IP version 6 aware application and name resolution. A dual stack host has both IP version 4 and IP version 6 protocol. Whenever we are talking about dual stack, it simply means the protocol of IP version 4 and IP version 6 addressing. Okay, so a dual stack host has both IP version 4 and IP version 6 protocol stack and has a new application program interface defined to support both IP version 4 and IP version 6 addresses and DNS requests. An application can use both IP version 6 and IP version 4 address. An application can be converted to new API with still using only IP version 4. In this figure here, okay, so DNS server is given and it will automatically convert into both the strategies like IP version 4 and IP version 6. So this is IP version 4 and IP version 6 aware system. So here in this figure, an IP version 6 and IP version 4 enabled application choose which stack to use. The typical default is IP version 6 and ask the DNS server for destination host address. In this example, it requests the host IP version 6 address. After receiving the response from DNS server, the application asks the source host to connect to the destination host using IP version 6. Microsoft Windows XP and Windows Server 2003 fully support most aspect of IP version 6 with the appropriate service pack installed. Windows Vista supports IP version 6, and these are the tasks of year 2008. Nowadays everyone is using Windows 10. Okay, so in this Windows 10, each and every package and API is installed default for IP version 6. IP version 4 to IP version 6 transition strategies and deployment. IP version 4 to IP version 6 migration does not happen automatically. So how it will done? Fine. Let us see the difference between IP version 4 and IP version 6. IP version 4 addresses are 32-bit long, okay, whereas IP version 6 are 128-bit long. And IP version 6 packet header is different from IP version 4 packet header. The IP version 6 header is longer and simpler. New fields were added to IP version 6 header and some old fields were discarded or removed. IP version 6 has no concept of broadcast address. Okay, instead it uses multicast address. Routing protocol must be changed to support native IP version 6 routing. Now come to IP versions 4 to IP version 6 translation or transition. So the transition from IP version 4 to IP version 6 will take several years because of high cost of upgrading equipment. In the meantime, IP version 4 and IP version 6 must coexist. There are three primary mechanisms for transition from IP version 4 to IP version 6. First is dual stop. Dual stack, both IP version 4 and IP version 6 stacks run on the system that can communicate with both IP version 6 and IP version 4 devices. In this case, we require additional memory support for the devices. Okay, and this will automatically increase the cost. Tunneling uses encapsulation of IP version 6 packet to traverse IP version 4 network and vice versa. And translation, a mechanism that translates one protocol to the other to facilitate communication between the two networks. So let us see how do we translate from one protocol to another protocol. Dual stack transition mechanism. So in this figure, a dual stack node enables both IP version 6 and IP version 4 stack. Application communicate with both IP version 6 and IP version 4 stack. The IP version choices is based on name, lookup, and application preference. This is the most appropriate method for campus and access network. During the transition period, and it is the preferred technique for transitioning to IP version 6. A dual stack approach supports the maximum number of applications. Operating system that supports IP version 6 stack include FreeBSD, Berkeley software distribution, Linux, Sun Solaris, Windows 2000, XP, Vista, and nowadays it is very common to use. Okay, so data link layer is there, frame or protocol ID, IP version 4 and IP version 6 stack is there, and it is communicated across varieties of protocol like TCP and UDP. Tunneling transition mechanism. The purpose of tunneling is to encapsulate packets of one type in packets of another type when transitioning to IP version 6. Tunneling encapsulates IP version 6 packets in IP version 4 packets. So in this figure, you can see IP version 6 header is there, IP version 6 data host. This is IP version 6 host. Dual stack router is installed here, and this converts into IP version 4, and dual stack router is also there, dual stack host is also there, and the header format includes IP version 4 header, IP version 6 header, and IP version 6 data. Dual stack router and IP version 6 network, IP version 6 host and IP version 6 host are both at both the side, and IP version 6 header, IP version 6 data. So this is encapsulated in IP version 4 data, IP version 4 packet. So the same thing is there, and only addition is that IP version 4 header is included. Okay. By using overlay tunnels, isolated IP version 6 networks can communicate without having to upgrade the IP version 4 infrastructure between them. Both routers and hosts are using, they can use tunneling. So there are different mechanisms that are available for establishing a tunnel. First thing is manually configured tunnel. For a manually configured tunnel, the tunnel source and tunnel destination are manually configured with static IP version 4 and IP version 6 addresses. Manual tunnels can be configured between border routers or between a border router and a host. Now come to semi-automated. In this case, Semi-automated is achieved by using a tunnel broker that uses a web-based service to create tunnel. A tunnel broker is a service on the IP version 4 network that receives tunnel requests from dual stack clients, configure the tunnel on the tunnel server or router, and associates the tunnel from the clients to one of the tunnel service or routers. A simpler model combines the tunnel broker and the server onto one device. Now come to automatic. There are three strategies: IP version 4 compatible, IP version 6 to IP version 4, 6 to 4, and 6 over 4. Okay. So first thing is a various automatic mechanism accomplish tunneling. So first thing is IP version 4 compatible. The tunnel is constructed dynamically using IP version 4 compatible IP version 6 address and IP version 6 address that consist of zeros in the upper bit and embedded IP version 4 address in the lower 32 bit. Because it does not scale, the mechanism is appropriate only for testing purpose, not for other purposes. Now come to IP version 6 to IP version 4. Okay, 6 to 4. The 6 to 4 tunneling method automatically connects IP version 6 islands through an IP version 4 network. The 6 to 4 each router has an IP version 6 address with /48 prefix. Okay, that is concatenation of 2002 colon colon, that is concatenation of 2002 colon 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 /16, and the IP version 4 address of the edge router automatically means a router with 2002 colon colon /16 is a specifically assigned range for the purpose of 6 to 4. Okay, the edge router IP version 6 address. Like if the IP version 4 address of the edge router is, suppose it is 192.168.99.1, the prefix of IP version 6 address is 2002 colon C0A8 colon 6301 colon colon /30 /48, not 30, because 0 hexadecimal number C0A86301 is the hexadecimal representation of 192.168.99.1. When in when an edge router receives IP version 6 packet with destination address in the range of 2002 colon colon /16, it determines from the routing table that the packet must traverse the tunnel. The router extracts the IP version 4 address embedded in third to 6th octet, inclusive in the IP version 6 next hop address. The IP version 4 address is the IP version 4 address of 6 to 4 router at the destination site. The router at the other end of the tunnel. The router encapsulation, it encapsulates the IP version 6 packet in IP version 4 packet with the destination edge router's extracted IP version 4 address. The packet passes through the IP version 4 network. The destination edge router and encapsulates the IP version 6 packet from the received IP version 4 packet and forwards the IP version 6 packet to its final destination. A 624 relay router, which is it offers actually traffic forwarded to the IP version 6 internet, is required for reaching a native IP version 6 internet. Now come to 6 over 4. Okay, a router connected to native IP version 6 network and with 6 over 4 in enabled interface can be used to forward IP version 6 traffic between 6 over 4 host and native IP version 6 host. IP version 6 multicast address are mapped into IP version 4 multicast addresses. The IP version 4 network becomes a virtual Ethernet for IP version 6 network. To achieve this, an IP version 4 multicast enabled network is required. Translation transition mechanism. This is another mechanism. Dual stack and tunneling technique manages interconnection of IP version 6 domain. For legacy equipment that will not be upgraded to IP version 6, and for some deployment scenario, techniques are available for connecting IP version 4 only nodes to IP version 6 only nodes using translation and extension of NAT technique. Okay, so this translation is an extension of network address translation technique. In this figure, an IP version 6 node behind a translation device has full connectivity to other IP version 6 node, and it uses NAT functionality to communicate with IP version 4 devices. Okay, so here IP version 4 only network and IP version 6 only network is there. IP version 6 address with this IP address, and this uh, IP address with IP version 4 address. Translation techniques are available for translating IP version 4 addresses to IP version 6 and vice versa, similar to current NAT devices. Translation is done at either at the transport layer or the network layer. NAT protocol translation, that is NAT protocol translation, also written as NAT PT, is defined in RFC 2766 Network Address Translation Protocol translation. Okay. ALGs use a dual stack approach and enable a host in domain to send data to another host in the other domain. This method requires that all application server to be converted to IP version 6. The DSTM translation mechanism may be used for dual stack host in an IP version 6 domain that have not yet had an IP version 4 address assigned to IP version 4 side, but that must communicate with IP version 4 system or allow IP version 4 application to run on top of their IP version 6 protocol stack. This mechanism requires a dedicated server that dynamically provides a temporary global IP version 4 address for the duration of communication using DHCP version 6, and uses dynamic tunnel to carry the IP version 4 traffic within an IP version 6 packet through IP version 6 domain. So this is the last topic of IP version 6, IP version 6 routing protocol. Okay, there are different routing protocols. The routing protocol available in IP version 6 include interior gateway protocol for use within an autonomous system, and exterior gateway protocol. Okay, interior and exterior gateway protocol for use between autonomous systems. Fine. As with IP version 4, CIDR, IP version 6 uses some longest prefix match routing updates to existing IP version 4 routing protocol where necessary for handling longer IP version 6 addresses and different header structure. Currently, there are some protocols like IGP. IGPs are uh, RIP new generation, RPing, EIGRP for IP version 6, OSPF versions 3, and integrated ISIS version 6. We will discuss in next topic. Fine. There are four topics which we will discuss all these things in detail. Now come to EGP. EGP multi-protocol extension to BGP version 4. Okay, this is BGP 4 plus. RPing. RPing is based on the IP version 4, RIP version 2, and similar to RIP version 2. RIPNG or RPing uses an IP version 6 prefix and next hop IP version 6 address. RIPNG uses multicast address like FF02 colon colon 9. The all RIP router multicast address as destination address for RIP update. RIPNG uses IP version 6 for transport. RIPNG uses link local address as source address, and RIPNG updates are sent to UDP port number 521. This port is assigned by IANA. Now come to EIGRP for IP version 6. EIGRP for IP version 6 is configured directly on the interfaces over which it runs. EIGRP for IP version 6 can be configured without the use of a global IP version 6 address. No network commands are used when configuring EIGRP IP version 6. EIGRP for IP version 6 routers IP version 6 prefixes. Then come to OSPF version 3 is similar to OSPF version 2 for IP version 4. It uses the same mechanism as IP OSPF version 2, but the internals of the protocols are different. This carries IP version 6 addresses. This uses link Unicast address as source addresses, and this uses IP version 6 for transport. Integrated ISIS version 6. Two new type of length values, TLB, IP version 6 reachability, IP version 6 interface addresses, new protocol identifier. Now come to BGP 4 plus. Multi-protocol extensions for BGP4 enables other protocol to be routed beside IP version 4, including IP version 6. Additional IP version 6 specific extension incorporated into BGP4 plus include the definition of a new identifier for the IP version 6 address family. In this lecture, we have covered features of IP version 6 including its 128-bit addresses, type of IP version 6 address unicast 1 to 1 or anycast 1 to nearest, and multicast 1 to many. Types of IP version 6 unicast addresses: global, aggregatable, link local, and IP version 4 compatible. Types of IP version 6 addresses: assignment, static, or dynamic, which includes using link local address, stateless auto configuration, and stateful using DHCP version 6. Types of IP version 6 name resolution, whether it is static or dynamic, using DNS server that have IP version 6 protocol stack support. IP version 4 to IP version 6 transition strategies including dual stack use, tunneling mechanism, and translation mechanism. And IP version 6 routing protocol including RIPNG, EIGRP, IP version 6, OSPF version 6, SS version 6, and BGP 4 plus. Okay, but this thing is not discussed in detail, the last topic. So we will discuss it in detail in next. So these are the topic wise summary for this lecture. In next video, we will see routing. Okay. So thank you very much. Have a nice day. Have a nice time. Bye bye.